Okay, this is solving systems of equations using elimination, part 1A, using addition. So, let's just refresh. We have been working on systems of equations, which is basically going to give us a value for x and a value for y, and that value for x and that value for y tell us where those two lines, those equations, if we graph them, would cross. So in this particular case, the value for x is 5 and the value for y is 4. So if we were to solve whether it was by graphing, whether it was by substitution, or our final method that we're going to learn, elimination, we would find the ordered pair for the intersection of the two lines would be at 5, 4. So, final way. Elimination. Here are some steps. This time it is going to be imperative when we use elimination that you write your equations in standard form. So this rewriting to align variables is just basically standard form. Okay? So as you can see in the first step, we have the equations written in standard form. The next one, we want to eliminate a variable. We either want to get rid of y or we want to get rid of x. Hence, the elimination method. Once we've eliminated that, we only have one variable left. So we're going to solve for that variable. And then once we're done with that, we're going to do just like we did in substitution. We're going to substitute the value or plug in the value that we found and then find our other value. So let's just quickly look at this and then we'll do some practice problems together. You'll notice that we have them aligned in standard form. Okay? We're going to eliminate a variable. Notice that my y coefficients are opposites of each other. What happens when we add numbers that are opposites of each other? In solving equations, we do that because we eliminate it. We can cross it out. Hence, eliminate a variable. So then I'm ready to add just like an addition problem. No coefficient here, so what could I put? 1. 1x plus 5x is 6x. Negative 19 plus 1 is negative 18. When I divide both sides by 6, I find that x equals negative 3. If x is negative 3, I can pick either one of these equations. They pick the top one. So x minus 2y equals negative 19. Well, instead of x, what am I going to write? Negative 3. So add 3 to both sides. You get negative 2y equals negative 16. Divide by negative 2, and you find out that y is 8. So my ordered pair is negative 3, 8. And to ensure that we are correct, you can substitute in for the final equation, your other equation, and it should make it true. All right, let's practice. Here's your first one. The opposite of x plus y equals 7. And x plus y equals 1. Okay, do I have the same coefficient for either variable? For both, I have 1. But notice, since we're going to use addition, we want the coefficients should be opposites. That's our goal, because if we're adding opposites, we know they will cancel. Well, look, my x's are opposites of each other. I set this up just like a standard addition problem. So I put my addition sign, opposite of x, but those are going to cancel. No coefficient here, so I can put 1. Like terms, 1 plus 1 is 2y equals 7 plus 1 is 8. If 2y equals 8, then if I divide both sides by 2, 8, or y equals 4. Let's figure out our answer. You said y equals 4. Let's plug it into the second one. plus 4 equals 1. Subtract 4 from both sides, and we find that x equals negative 3. Substitute it back in. Is the opposite of negative 3 plus 4 7? Yes. So my ordered pair is negative 3, 4. Okay? Let's do another one. The opposite of 4x plus 5y equals 17. 4x plus 6y equals negative 6. Are our coefficients opposite in either of those? X. So we're ready to add. Those are going to cancel or eliminate. 5 plus 6 is 11y equals 17 plus negative 6 is 11. Y equals 1. Okay? Let's put the second one. 4x plus 6 times 1 equals negative 6. 4x plus 6 equals negative 6. Subtract 6 from both sides. 4x equals negative 12. X equals negative 3. X is negative 3. Negative 4 times negative 3 plus 5, y equals 17. 12 plus 5y equals 17. Subtract 12. 5y equals 5. Y equals 1. Wait a minute. Not. What? Oh, I didn't. So we know that we're correct. Lost my train of thought. Do it early in the morning. So my ordered pair is negative 3, 1. So that double checked right here that y should be 1. Let's do one more. I'm going to give you a minute to start. Now I'm going to work slowly behind you. That concludes the elimination method part 1A.